Area of a triangle. Consider a triangle ABC. Let's say these are the coordinate axes. Draw perpendiculars from each of the vertices to the x-axis. Let's say these points are P, Q, R. Coordinates would be x2, 0, x1, 0 and x3, 0. We can write area of triangle ABC as area of quadrilateral ABPQ, that is this quadrilateral, plus area of quadrilateral AQRC. If we add these two quadrilaterals, we would get area of this entire diagram. So if we want the triangle, we need to subtract this quadrilateral minus area of BPRC. If you observe, these three quadrilaterals are trapeziums. A trapezium is a quadrilateral in which one pair of opposite sides are parallel. If the parallel side lengths are A and B and the distance between them is h, then area would be half into h into sum of parallel sides. Applying this, we get area of triangle ABC would be ABPQ trapezium. We have BP is parallel to AQ. Half into distance between parallel sides is x1 minus x2 into sum of the lengths would be y2 plus y1 plus the second trapezium AQRC. AQRC, distance between parallel sides would be x3 minus x1 into lengths would be y1 and y3 minus half into BPRC, distance between parallel sides would be x3 minus x2 into this is y2 and this is y3. We simplify this expression, we get half into x1 y1 plus x1 y2 minus x2 y1 minus x2 y2 plus x3 y3 plus x3 y1 minus x1 y3 minus x1 y1 minus x3 y2 minus x3 y3 plus x2 y2 plus x2 y3. We observe there are some cancellations to be made. So the remaining parts can be written as x1 y2 minus x2 y1 plus x2 y3 minus x3 y2 plus x3 y1 minus x1 y3. This is the expansion of the determinant x1 y1 1 x2 y2 1 x3 y3 1. So this is the area of the triangle ABC.